Welcome to the 9th episode in a series where I'm giving some tips and tricks on how to program using the Arduino platform. It's a bit of an unfortunate intro since there isn't actually going to be anything to do with Arduino in this episode. Instead, I will show you how to make this combined rotary knob and button that I was using in my last video, episode 8 of this series. Check that out if you missed it. And here's a quick look at everything you'll need to prepare in advance. There's really not that much to it, and I'll provide more information on the individual parts as we progress through the video. The 3D printed parts shown are actually straight off the 3D printer without any extra processing. I'm planning to make the STL files available on Thingiverse or Printables or something like that. Check the description for more information. The design is intended to be fairly tolerant to some degree of printing variations and require extremely little processing. Even so, it's important for you to print the parts with the correct settings and orientations as shown in this video, so please follow that closely. In fact, this is only the second time that I've actually made this knob, and it went together very quickly and easily. However, I did break out a brand new roll of PLA Plus for this video, and this resulted in a slightly under-extruded result due to filament differences, and while that's not the best, the result was still very usable. But I think it was a pretty good reminder of what others might experience when trying to make this knob. Anyway, if you find things are fitting a little bit too tight or too loose, then simply tweak your extrusion multiplier settings in your slicer until you get a good fit. Now, the TPU rubberized grip is completely optional, you don't have to use it, and of course you could always consider redesigning the grip portion of the knob to suit your specific needs if you want to, that is. Post 3D print processing just requires a simple inspection and removal of anything protruding, and I suggest you give special attention to any surfaces that interface with each other. Now, this is the surface where the sliding pins will locate, so I recommend some very minor adjustments to ensure the area is somewhat flat and even. Here I'm checking the main rotating interface to see that it fits and moves smoothly, and obviously making adjustments as need be. Really should only require some minimal adjustment. You don't want to be cutting in there too heavy or anything. Unfortunately, the fit is actually a little bit looser than I normally would prefer, and that's due to that under extrusion. But even so, it's still going to be usable, and everything seems to be moving nicely. For the pins, all you need to do is just scrape off any elephant's feet or high spots. You don't need to overdo this either. And of course, make sure the pins fit in the holes in the top of the cap. Sometimes I've found it necessary to clear around the edges of the holes, but in this case, thanks to that lovely under extrusion, it's going to be fine. I don't need to do anything. Now you need to make sure that those pins are going to be able to go in deep enough into those holes so that they can line up with the bottom edge of the cap here. You should also do a light sanding or scraping of the bottom edge of the cap. I used sanding for this before, but scraping like I'm showing here, this seems to work pretty good as well. Now this edge actually needs to be flat and smooth so that when the cap is pressing down on the buttons, it can still smoothly rotate. So that's what I'm trying to achieve here. And after you've got that done, make sure you just give it a quick scrape around the internal edge and make sure you clean out any of the garbage that's inside. Now I'm also just using a cutter knife here, just as a final check to make sure those sliding surfaces for the pins are actually flat. The special magnet is actually press fitted in, and I'm doing that using a small hobby vise. And before you try and press it in, however, you will just want to make sure that there are no large elephant's foot on the internal edge of the hole. If there is, then scrape it off before trying to press the magnet in. Next up is preparing the string. Now the first thing you want to do is make sure that the spring actually fits into both surfaces before you actually go any further. As for sourcing the spring, well, you're pretty much on your own for that. I'm sure there are plenty of places you could find springs. For me, I just have a pile of springs from stuff that I've scrapped over time, and that's where I got this one from. Now, springs have all different levels of strength and reboundishness, or whatever the word should be, so it's pretty impossible for me to give you a specific length as to where you should cut it. Simply test the spring and cut it at a point where you feel it gives a moderate amount of pushback on the cap. Maybe even cut it a little bit longer at first and test it, and if there's too much pushback, then maybe cut a little bit more off. Once you've got that cut to length, you can bend the end a little bit so you can try to get the spring to sit a little bit flatter. You can see my final test here, and the pressure all feels just about right. So next up is gluing the cap in place, and that's going to make use of the pins. So before we actually get to doing that, let's just make a final check and ensure that all the pins actually fit in their little slots and they all can slide smoothly. Then you're going to have to hold those 3 pins into place and then place the spring in the cap, cut end towards the bottom, and then slide the cap on till you're about halfway or so, all while holding those 3 little pins in place. You should also be careful that the pins are aligned with the holes on the side of the cap as you put the cap on. And once you've got that done, you can then place in the final pin. Push the cap all the way down and make sure those pins fit in the holes in the top of the cap. Now carefully put it down so you can prepare the CA or super glue needed for the next step. I'm also going to use some CA glue accelerator to speed up the process a bit. I also recommend you find that if you can, that's for sure. Alright, now push the cap all the way down and align your first pin to be glued. Use a flathead screwdriver to push the pin in so it is perfectly flat with the bottom edge of the cap. Now you want to be holding pressure so the cap is fully compressed, of course, but also applying some side pressure to push the pin against the side wall of the cap. Now using a sewing pin or something similar, fully fill the hole in the side of the cap with CA glue. Of course, double check the position of the pin is correctly centered with the hole and level with the top of the cap before you actually start sticking the glue in. And use the pin to stir the glue around in the hole a bit to make sure you're getting good penetration. Then use the CA glue accelerator and then wait for 10 seconds or so for it to set. While holding the cap down firmly, now spin it around so we can start work on the pin on the opposite side. Then we can repeat the exact same process again. Once the glue is set, at this stage you can actually release the cap if you like, and this can be useful to pull up the remaining 2 pins into position. Then go ahead and follow the same process to glue the remaining 2 pins in place. And now that we're all done with the pins, of course do a quick movement check and make sure everything is working properly. As you can see, the amount of movement is actually pretty tiny, so don't be surprised or anything when you see it, it's actually correct. Now to glue in the main body, and a big warning here to make sure you install the rotor so the magnet is facing down towards where the sensor will be. Don't get it in the wrong way, because once you glue it, there's no going back. Now I'm applying some white silicone grease to the rotor. I do this to both make the movement a little bit smoother and also add a little bit of gravitas to the feel of the knob. Now how much grease you use, or if you use any grease at all, well, this is completely up to you and depends on what type of feel you're going for with the knob. Just make sure if you do use grease that you are careful you don't get it everywhere, especially near the gluing surfaces. Now I'm using that sewing pin again to carefully apply a reasonable amount of CA glue around the corner of the gluing edge of the lower main body. And then go ahead and join the lower and upper body parts together. Make sure you firmly push the upper part fully down on the lower part, closing any gaps. And while holding it all firmly together, apply the CA glue accelerator and continue to hold it for a little while until you wait for it to set. Now apply a good amount of glue to the internal mounting edge of the knob assembly and then carefully join the main body assembly with the knob assembly. And while firmly pressing it all together, again apply some CA glue accelerator and then wait for it to set. And once it's set, do a final check to see that if everything is still moving as expected. Now if you've printed the TPU rubberized grip, go ahead and slip it on at this point. I guess you could also glue it on, but I found that to be unnecessary. And you can also see this accelerator leaves this white residue. If it bothers you, then scrape it off or file it off, or maybe even use some chemicals to remove it. But in this case, I'm not going to bother. So you're going to need some of this infamous green Chinese prototype board for this next step. They sell it by the truckloads in AliExpress, so I'm sure you're not going to have any trouble finding it. You need to cut off a piece from each end. You can do this easily enough with a pair of cutters. And once you've cut it off, you need to then file it down so that they're between 9.8 and 10 millimeters wide. Now you can source these switches super cheaply on AliExpress. Information here on the screen for you. First, just solder one leg of the switch to the board, aligning the switch to the correct position. The location of the switch should be closely aligned to the edge of the board, just a little bit overhanging. The leg of the switch will be basically centered to the line of the holes. Now the position is not that super critical, but it can't be too far off either, so take a little bit of care with this step. So once you've got the position correct, solder the other leg. You should also make sure that the switch is flat with the board and not floating above it. Now you could always just run wires directly to the board or use a different type of connector if you like, but for this demo I am simply using PCB header pins. Solder one leg in place before soldering the other. Now I got this fine stranded wire again from AliExpress, and I'm going to strip off the insulation around about halfway or so. Then twist the strands all together before going ahead and tinning them. The method for doing the soldering is as I'm demonstrating here, and I'm just going to snip off the excess with a cutter knife. And if you like to do it, obviously clean off any flux residue with IPA and a toothbrush. I've already completed the other one here, as you can see. One thing you need to check for, however, is the solder protrusion on the bottom of the board. You can see this one has a bit of an outie. So I'll use a cutter knife to trim off and make sure that it is flat with the board. And the other one here is all innies, so there's no problem here. Then go ahead and use your meter to make sure that your switches are working correctly before we attempt to install them. To mount them, I'm using M2 round head screws with a thread length of approximately 5mm. I get all 4 screws started first before driving them home. I actually then used a power screwdriver to drive them home because that worked well with the last one of these that I made. Unfortunately, due to the under extrusion, the thread fit was looser and I managed to strip one of them. So in reality, I actually suggest you stick to just using a manual driver unless you really find it tough to screw them in. And there you go, all done. This is how the buttons should work. For mounting the sensor board, I'm using M3 countersunk screws with a total length of around about 6mm. And I'm using countersunk screws to help correctly align the sensor board with the overall assembly, which in turn should mean the magnet is in the right spot for the sensor. As you can see, this time I'm just manually screwing in all those screws and obviously being careful not to over tighten them. And there you go, you can sort of see how the magnet there is positioned above the chip down there. Alright, all done. Even with filming, it just took me about under an hour to assemble all of this. Actually, I was pretty surprised at just how easy it was. So yeah, not too bad. So that's it for this episode. As always, I hope you found it useful. And of course, I hope to catch you in the next one. So, see you then.